Yeah. I thought maybe this would be most beneficial for you rather than just handing these papers out and throwing caution to the wind and just saying, hey, work on these. Because then I think it'd be very easy to get frustrated, and then when that happens, then I think it's just even harder to concentrate and just getting this done for the benefit of your own knowledge. And actually started working on a different computer and stopped recording, so that's why you see some of this information on here. All right. So what I want to do is, now that I've got two computers down here, so I was thinking it was number 5 and number 6 I was going to show you, but actually, it's actually number 6 and number 7. So this is actually number 6. It's on your back page. Number 5, we'll talk about when we get back on Monday. Okay. And the reason that this is so important is this will help you when you have to do your story problems. That's what this one was up here for. This is an example of what you actually see on the back. And I told whether it was the freshmen or the sophomores, the more exposure we have to this, for those of you who maybe have played softball before, you're facing someone tough as their pitcher. Maybe you strike out the first time, maybe you make contact and follow them off the second time, and then maybe the third time you got success. So the more times that we have exposure to this, the better chance I think maybe we'll have success with that. Anyway, so what I had down here earlier, before I shut this off, because I realized it wasn't recording, is I had this row up here, and what we're illustrating here is the variables r and x. Okay? And that's what we're illustrating here as well. R is just any alkene group. Okay? It could be one carbon in length, a CH3 group or a methyl, or it could be a C3H7. This is also an alkyl group. It's just a little longer. So that also would have the variable R. And as we know, halogens have the variable X. So on your flow chart, if you're looking to see how this reaction would proceed, what you're seeing is we're starting in the middle, okay, where you have your benzene ring there, and you're looking to see what you're reacting that with. And in problem number 6, we see we got methyl chloride. It's just CH3Cl. So what that is illustrating in that chart is if you have any alkyl group, so it's any type of R, and an X is any halogen. In this case, it's, as you can see, chlorine. So what that means then is as this proceeds, because of this sulfuric acid, this R group then gets attached. So anytime you're making toluene, you just don't take a methyl group and attach that to the benzene ring. That's just not how these reactions work. And that's how that flow chart will hopefully help you. So again, any R is any number of carbons, and it's an alkyl group. Methyl, ethyl, propyl, isopropyl, those are all alkyl groups because they're all derived from alkenes. Okay, so in this case then, it doesn't fall down. All right, so what we see here then, again, this R group, this is probably about like at 7 o'clock on your flow charts. And what that is saying is that, again, benzene plus any alkyl halide, in this case methyl chloride, will react as both a substitution and an addition. Because, remember, there was a hydrogen here. It's now been substituted by R, which is an alkyl group, and that's the substitution. The addition was this hydrogen then would grab that chlorine group. Okay, so if you really wanted to be specific, you could write plus HCl. Now, whether you put that down, that's entirely up to you. Again, for those of you who take this in college, you may have to put that information down. Maybe yes, maybe no. So if you want that exposure now, that's fine, but we're not going to count any points off for this. So if you like putting that down, that's fine. Then I see for number 7, okay, we already have toluene. Okay, so we got our CH3 group on there. And what that would mean then, okay, let's go ahead and put toluene on here first. Okay. And remember, now when you're looking at the flow chart, you're not starting start in the center like what we are here. We're starting with the variable R, because remember, R is an alkyl group. This could be even propylbenzene instead of just methylbenzene, or in this case, the common name, toluene. Okay, so in number 7, it looks like we've got toluene plus chlorine. So now that we've got something on there already, and we're adding heat here. Oh yeah, I see what happens is when you're looking down these, it's very important to understand what's happening. If you're adding heat, that is going to be different than adding a what do I want to say, a metal catalyst. So I should not sulfuric acid. I should have I don't know. We'll just put some nickel chloride in there. I don't know what you have in your problems. It's probably some sort of other metal halide. So now what we see happening, rather than a metal halide here, heat is going to do something different than this in this case. And it'll illustrate that on your flow chart. It's going to say something about heat. It's going to say something about a metal halide. In this case, if I remember correctly, what's going to happen is because it's heat, you're only going to get one product instead of two. Remember, we spent time saying anytime you have a reaction, this is going to determine what is going to attach onto there and where. If this was a metal halide, you would have an ortho position and a para position. Okay? Because remember, alkyl groups, halogens, and OH groups are all ortho and para directors. So we go here and here. That's again if that was a metal halide. We don't have that. We've got heat instead. So what happens in this case, okay, we still have our methyl group, but now we've got Cl on there. But one of the things I want you to be aware of is that it's not written correctly. Okay? I want you to take a moment and see if you can figure out why that is. And I did that intentionally because you know there's nothing paused on the video or anything like that. Sometimes it's a nice coincidence that it happens this way that we can actually have this illustrate. Okay, so this is what's actually happening. Switch. So, what happens, remember, we said you can always draw the structural formula. In this case, we see we've got the molecular formula there instead. What's actually happening here, remember, carbon being in column 4 can only have 4 bonds. So what you're illustrating here, and why you got to be careful, is that this has 1 bond here. Then you're saying there's 3 on here, so there's 4. We can't put a 5th one on here. So what you can do, we always said you're never wrong by using your structural formula. So what's happening here, rather than CH3Cl, you actually have CH2Cl. Because now we've illustrated this carbon's got 4 bonds now. There's 1, 2, 3, and 4. And there again, this is just another type of, you could say a substitution as well, because what we see happening is one of these chlorines attached onto here because of heat. Then this used to be a hydrogen on here, because remember we had CH3. That is now a Cl group, and that's because of heat rather than a metal halide. And you can also have plus H. Again, we're not going to beat you up over that. Should you not have this on there as well? Okay. So I'm glad I had time to go over that. Now, whether you actually do this or not during this class period, maybe yes, maybe no. It's important we pay attention to, okay, where are you at on the flow chart? What is on the grain, if anything? And what are you reacting it with? Is it either heat or is it with a metal halide? Okay, we'll wrap this up here right quickly with this word problem. And you may need to back up to see how you actually attach that methyl group to get toluene on there. Okay, we'll wrap this up again very quickly. Hopefully this isn't bringing back bad memories from last spring. I didn't bring my microphone home tonight. I wish I would have done that. It's kind of too late to go back to the school now. But it's saying illustrate a mechanism. This is very similar to number probably 17, 18, 19, somewhere in there. Illustrate a mechanism for the production of orthofluorotoluene and parafluorotoluene. Okay? So what we can do is put this prediction up here. This is what slip on it. Okay. So we know that one of these, CH3, and we've got fluorine group there, and we know that that's what we're looking for. It says orthofluorotoluene. Okay, toluene just means this. This is in the ortho position, and parafluorotoluene. Okay, and in this reaction, I can guarantee you, you are not utilizing heat or using heat, because if you do, you're going to end up with that fluorine on there instead of on these different groups on what this word problem is asking. Okay, so the first thing we need to do, it should say starting with benzene. Okay. We need to get that methyl group on there first. So we can't just write something like that. It just doesn't go on there like that. Okay. And you can't use methane either. Okay. Again, on your flow chart, it says R and X. So in this case, we're just going to go ahead. You could put any halogen on here. You could put I if you wanted to, or F, or Cl, whatever you're most comfortable with, because it's R and X, an alkyl group and a halogen. Okay? So remember, as you're reacting this, don't do this, because if you do that, okay, after you get this on, this isn't going to attach the way we want it to. So it's not heat. We're going to use, go ahead and do some FEI. Now what we see happening, now we've got our alkyl group on there because of this metal catalyst. Okay? So we're getting closer. And I hope this isn't totally intimidating, just doing this for the first time. We'll talk a lot about this on Monday again, but again, we're just slowly getting into more practice with this. And we hope this will help you out in the long run. Okay? So now we've got our toluene on here. We just want an ortho and para position for this fluorine now. Okay, now in step 2, we're going to take our toluenes, okay, and we're going to react that again with now some fluorine, it looks like. And again, don't do that, because if you do, that's wrong. Because that fluorine is going to attach onto this methyl group instead. So we have to have some sort of metal catalyst. Again, Fe, we can do F3. Now we've got our metal catalyst telling this halogen, okay, you're going to react, but you're not going to attach onto here. Since it's not heat, it's going to give you your para and ortho positioning, because this is directing where that's going to attach. Now we've got our, wish I had my full whiteboard. Do up at school, just like what we're looking for there, and then you would write plus, and that's way down here. Now we've got our parafluorotoluene. Okay, those word problems can get to be a little tricky. So again, the more exposure we have to that, the better off we're going to be. Okay. I understand there's nothing easy about this. So we just Try not to get too overwhelmed by it. Yeah, I know that's easier said than done. This is where, unless you're sitting on the corners, look to your left, look to your right, and you're here to help each other out and pick each other up. And that's what good teammates would do on the volleyball court as well. I think you would agree with that statement. All right. So we've already got this up to 15 minutes, so I think I'll stop there. Again, the best thing to do is look to see where you're starting at. If it's just benzene, you're in the middle of that flow chart. If you have toluene, well, then you need to see, well, what are we reacting that with? And is it heat or is it a metal catalyst? Okay. So I think that's probably a good place to stop now because we're about up to 16 minutes. So hopefully our head isn't spinning too fast. So again, we'll talk more about this on Monday. So have a great weekend and we'll catch up to you next time.